All right, Unit 3, Lesson 2. We're going to be able to simplify expressions with negative and zero exponents. All right, so there's something called the zero power rule. That means anything to the zero power equals 1. Anything. You can have negative 15a 5b 12, to the zero power, that equals 1. Right? Everything in the parentheses also, if it's raised to the zero power, it's a 1. Okay? So 3 to the 0 power times 3 to the 6 power. The bases are the same, therefore you can add the exponents, which is 0 plus 6 is 3 to the 6. That same as 1 times 3 to the 6 is 3 to the 6. Okay? Bases are the same. Add them all up, get the 4. Oh, there's that other example I just gave at the top there. All right, and then even when it's complicated, notice that it's just this that equals 1, okay? So we really don't have to concern ourselves with it. 2 over 5, x to the third minus 3, right? This little bit right here. X to the third minus 3 is x to the 0. That is a 1, so the x's are gone, okay? And then 5, oops. This should be 5 minus 2. We'll fix that on the sheet. Alrighty, and 2, let's see, times 1. Okay, so that should be y3 over 5. That's all that's left, because the x is left, the z's is 0, the fraction stays, and there's more y's. There's more y's on top than there are on the bottom, so there's 3 left over. Okay. All right, for negatives, let's say you're crunching through a problem and you do a little subtraction and you end up with a number that has a negative exponent. You need to then convert it to a positive exponent by moving it underneath the the division bar. Okay. This one right here, if it's on the bottom and it ends up negative, then you need to move it up to take the negative off. Don't forget, you can also distribute, look at this one. This is a to distribute that negative. And then to make them positive, you need to bring the b up and the m down to take the negative off. All right, so base is the same. You're still adding exponents, even though there's a negative in there. You add all them together, and what do you get? You get a negative 2. The negative 2 will turn into that. Okay? The let's see, we have to distribute this 5. That makes 15. Distribute the 5, that makes 10. And to remove this negative in front of the 10, it needs to move down. Keep the, and it has nothing to do with this one. This is a positive exponent, so it's currently it's on top, so it stays on top. Okay, that one comes down. We distribute a negative, gives you negative, distribute a negative to a positive 1, that gives you a negative, and then each of them need to be moved to remove the negative for your final answer. All right, 3 over here, the bases are the same, so we can subtract the exponents because it's a quotient rule. So this is going to give you this, which will give you 1 over 3 to the 2, which gives you that 9. Okay, so negative 2 subtracting a negative 3, that's one big plus. So negative 2 plus 3 is 1, so you don't have to put the 1. Don't forget, when you just see something sitting there, it's like that. it's also like that, okay? And A's are also 1A's. So a lot of things you don't see are 1s on there. All right. Let's see. This one looks complicated. So this one has work we can do in the parentheses first. So we must do that before we distribute that -2. So a -12 divided by 10. If you just had a -12 divided by 10 and you want to reduce it, it's still going to be negative. You divide this by 2 and divide this by 2, you get a 5, and you get the 6 there. So that's -6/5. Excuse me. And then you have x to the -3 minus 1 gives you x to the -4, which means it goes on the bottom. Okay? Some people kind of take this and move it down here, and that'll give you 4 on the bottom. Either way. Okay? And then we're ready to distribute this -2. So this is -6 to the -2. Take that -2, distribute it to the 1 that's next to the 5. That's a -2. And then 4 times a -2 is a -8. So all of them, all 3 terms, this one, this one, this one, they're all on the wrong side. So to remove them, this has to come down. This has to go up. It's just a coincidence you're moving them all. You have to look at each one individually. A -6 times a -6 is a +36, and I have no idea where that 1 came from. Okay? All right. Let's practice some of these. No negative exponents in your final answer. That goes for the homework. That goes for the tests. I don't accept them. Nobody accepts them. The way it's kind of explained is the negative exponents in this type of problem is used to help with calculation. It is not something you want to leave on there, okay? All right, so let's distribute first. So 6 to the 4th, y to the 12th, z. What is 0 times 4? That's 0, right? So that means it's just a 1. And then when you say times y to the -2, that just sort of gets tacked on there, okay? You can move it to the bottom, take the negative off if you want. I don't want to confuse anybody, but that would be the same thing as tacking it on the end there. But that's up to you. You don't really need to do that. That'd be 6 to the 4th, y to the, 12 minus 2 is 6 to the 4th. I'll figure out what that is in a second. To the 10. Even if you did it here, you're still getting y to the 10th left on top, right? And 6 to the 4th is 1,296. 1,296. Y to the 10th. Let me make this thicker so it'll be neater. Sorry for the messiness there. That just looks so messy. That's a little better. All right, number 2, nothing. Notice there's no exponent out there, okay? No exponent out there. I am ready to go ahead and multiply. And what is a y to the -4 plus a -2? Because we're multiplying, remember, we just multiplied 6 times -2. That gives you -12. But when you're multiplying bases that are the same, you're adding their exponents, okay? You're not multiplying exponents unless they're on the outside of the parentheses. So that's -12. This is a bigger negative. We're adding. And our final answer, which is weird looking, but you got to get used to that. This term has a negative exponent, so it needs to go on the bottom. Okay? All right, this one, okay, the x has to come down to get the exponent off, the negative off. Then it has to go up. They're not like terms. You can't reduce it. That's done. Okay? This one, we are distributing this -4 to the -8, makes a positive, what, 32? Distribute z, it's one negative, so that's a -20. So our final answer is x to the 32 over z to the 20. All right, this one here, just this term is negative. Has a negative exponent. The 4 has a positive exponent, so it stays where it is. Positive terms stay where they are. Okay? So if they're on the bottom, they stay on the bottom. If they're on the top, they stay on the top. You have to move terms that have negative exponents that on that last move, so you don't turn in things that have a negative exponent. So that means this goes up here, and that's done. Okay. All right. Lots of stuff in the parentheses, and then I distribute. So I need to work on the parentheses first. So -9. 17x is on top, 5 underneath. That means I have more left on top. I'm going with a 12, and then y to the 6, and this is still out there. So distribute this 1, -1 to the 1 would be, this is -9 to the -1. Stick with the process there. This is 12 times a -1, right? Which is a -12. And this is y to the 6 times a -1. Sorry, so all of the terms are on the wrong side. So everything gets to be moved. So in the book, you'll see when they have a -1 out here, they just flip everything. But I'm showing you why. Because when you distribute that negative, it makes all the exponents negative. So that means the y to the 6 comes up, the -9 is on the bottom, and x to the 12 is down here. So when you multiply things by -1, it just flips everything, all the terms, okay, because it makes them all negative. All right, this one here, we have 18 to the second. We have y to the -16, right? So because this, I can multiply them. And 6 to the -2, and y to the -8. All right, so 18 squared is going to be staying on top. Oh, guess what I forgot to do? I had a bunch of stuff in the parentheses, and I completely ignored it. I need to handle that before, because it's just silly to distribute this -2 to all this stuff in here when it can be reduced to start with. So PEMDAS says, go back in here and fix this. So this is 6 into 18 goes 3 times, and then 8 minus 4 is 4 left on top. And you know what? I don't even have a fraction anymore. This is so much easier this way. So this is just 3y to the 4th now, raised to the -2nd power. That looks better already. So 3 to the -2, y 4 times -2 is -8. So my final answer is 1 over 3. Well, no, I gotta... what is 3 to the 2nd? Let's step through this for a second. Sorry. So this is 3 to the 2nd, y to the 8th. And then that's going to be 1 over 9 y to the 8th. Let me check. Yeah, that's what I had before. Okay. All right, let's see. Distribute, -8. Distribute, positive 56. That's strange. This is y to the -8 minus 56 gives me y to the negative, what, 64? So that means that goes here. All right, this is the same as 1 over x to the -8, which is the same as x to the 8th. If it's on the bottom, bring it up. You don't have to put that, but that's what's there, okay? All right, distribute the 2, -6, 2, y, 4, x to the -10, z to the 2. -6 times -6, 36, y to the 4th, z to the 2nd, because I'm putting the x to the 10th at the bottom. Okay, that was the one term that was negative, so that has to go down there. Let's see, I have this term times this term, so I need to handle that first before I distribute. So this times this is a positive 12. Y to the -4 plus 2 is y to the -2. Z to the 1 plus another 1 is z to the 2. So I can put this back together and then go ahead and distribute that -2. So -2 times the -2 is a positive 4. And z2 times a -2 is a -4. All right, so I need to move all the negatives. So y to the 4th is positive, so it stays here. 12 to the 2nd goes down here. Z to the 4 goes down here. This needs to be processed, so the final answer is y to the 4th over 144 z4. Wait, I lost my x. Where did my x go? I missed it altogether. Right there was an x, sorry. Let's see. I'm just trying to finish this quickly. Let me shove it over here. That's a 1. It's a -2, so that's a -2. So there's another x. -2 times a -2 is a positive 4. Oh, wait. Okay, sorry. Sorry. I'm so sorry. I'm in a hurry. Let's not be in a hurry. Let's do this correctly. Sorry about that. Okay. This whole thing times this whole thing. So this times this is 12, right? Put this back in the parentheses. X, y to the -8, z to the 2. Put the -2 back. 12 to the -2, x to the -2, y to the positive 16. Something happened again. Oh, I multiply. Oh. All right. 3 times the charm. Sorry. X. What did I do wrong? I took this here, and I'm supposed to add them. Okay. Which should give you a -2, right? 1 and a 1 is 2. -2. All right. 12 to the -2, x to the -2, y to the 4, z to the -4. All right, so positive, 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 positive. So, sorry, y to the 4, that's a 4. 144x to z4. Let me check that. Yes, that should be correct this time. Oh no, and the next one's a challenge one. All right. Definitely need to reduce this mess first. So -2. All right, that should be a -1/5. And x to the -3 minus 1 is x to the -4. So that's down here, which makes it positive, right? y5 minus a -2 is plus a 2. So y to the 7th, so that's here. And z1 minus 2 is a -1, so the z stays here. Think about it. There's one z on top, 2 z's on the bottom. That means they reduce to leave you 1 on the bottom, okay? 5 on top, -2 on the bottom. The y's come up, that makes a +7, so we're good. I just have to kind of mentally check that, because here, we'll look at the paper too. And that looks right. Okay. Then distribute the -3. So that is a -1 to a -3. Yeah, I had to keep that negative here. Because, see that negative there and reduces to a 1, I would have lost that negative if I haven't kept it, okay? So that would be the one time I would go ahead and keep a 1 to make sure that negative gets handled correctly, okay? I know we've been like losing a lot of 1s because it doesn't matter. In this case, because it's -1, -1's way different than a +1. -1, I got to keep track of it, okay? Okay, let's see. So 5 to the -3, y to the -21, x to the -12, z to the -3. I'm checking my notes. Yep, that looks good. All right. All right. That means everything gets flipped. I think in the book they flip things first, but I just like to keep with the same process for everything. So that means this goes down here. This goes up here. And then things have to get processed. So 5 to the 3rd is 125. 5 times 5 times 5, right? X to the 12, z to the 3. And then -1 times -1 times -1 is a -1. Y to the 21st. Yep. Yeah, it's typed in a funny order, but yes, that is the answer to that one.